thank you for tuning in. Welcome to a new episode of the Passion for Technology podcast by EBV Electronic.
Welcome to the Passion for Technology podcast. In today's hyper-connected world, embedded processing solutions are the foundation of everything we build in electronics. Think about it. From microcontrollers and processors to AI accelerators and system-on-modules, they're all enabling real-time data processing right there in the devices themselves. These embedded systems are practically everywhere we look now. Whether you're picking up your smartphone, working with IoT sensors, stepping into one of today's increasingly automated vehicles, or walking through a modern factory floor, embedded processors are quietly doing the heavy lifting. And the market reflects this ubiquity. The analysts at IMARC have some interesting numbers for us. They're projecting the global embedded processor market to hit $21.2 billion next year. But that's just the beginning. They're forecasting this to grow to $36.6 billion by 2033, with a compound annual growth rate of 5.98% starting from 2025. Let's dive into what's driving this growth. Today we talk to Ulrich Schmidt, Director of the Embedded Processing Technology segment at EBV, about where this growth is coming from and what technology trends are shaping the embedded processing market. Hi, Ulrich.
Hi, Mustafa. Thanks for being on this podcast.
Yeah, thank you for taking the time. Ulrich, before we dive deep, what's the most exciting embedded project you're working on right now? I'm thinking autonomous vehicles, drone tech, or maybe something in human-machine interfaces that's pushing boundaries.
I see. There is actually no particular market or application that I would in particularly highlight. This because there are so many things going on across the different vertical segments and technologies we cover. And while I'm looking at AI more in general, and to be more specific at Edge AI, for more than 6 years now in my role for the embedded processing segment that was formerly called Edge AI and Computing, certainly with the hype of ChatGPT, AI also got a push within the embedded space that is currently ramping up.
Let's talk market dynamics. Where are you seeing real momentum in terms of demand and growth for embedded solutions?
Within EBV, I would say as the industrial market has the biggest share within our business, it's many products and solutions we see in this industrial space. As you mentioned in your introduction, still IoT with all the secure and connected devices is one of those growth drivers that I currently see that still evolves, which is basically added with all the new product features we see in the different solutions from our vendors or partners.
You've briefly mentioned AI, and AI is obviously transforming our industry. How is this revolution specifically reshaping embedded processing from a technical standpoint?
While we are not yet there in all areas, AI is certainly becoming one of the driving technologies for new products. Over the course of time, silicon manufacturers integrated neural network accelerators into their products. We see a stronger demand, for example, for large language models in the various products. It's things like generative AI. I'm thinking more from a generic point of view. For example, when it comes to produce code or generate code for microcontrollers or NPUs that help or get customers to market more quickly and supporting customers with solutions for the different products.
Now, tying AI to embedded processors, Ulrich, could you maybe walk us through some concrete examples of AI running on embedded processors? You know, things like speech recognition for interfaces or computer vision applications that our listeners might encounter.
Right. Thanks for this question. Our focus adopting AI was actually driven by starting with vision-based systems that typically require more AI processing power. But there is solutions now coming also from the MCU side. But once again, we started with vision-based applications that are accelerated, and speech processing or natural language processing is one of those things I see changing the type we operate with machines for human-machine interfaces. Yeah, simply to operate machines or robots in natural language.
And Ulrich, what would you say are critical factors for AI processors today? Things beyond raw processing power. I'm thinking along the lines of, energy efficiency, maybe physical footprint.
Right. It's part of the sheer AI power. There is the electrical power that is pretty much proportional to the calculation power. And typically in industrial environments, there is a certain power budget we have to meet because if you think of products that have to operate 24/7, things like a fan, everything that is basically something moving could cause issues over the lifetime of a product are not that very much accepted. So, as I said, to stay within a certain power budget, this is kind of related to the processing power we can see or utilize typically in industrial or closed environments.
Here's an interesting comparison for our listeners that I'm thinking of. How would you say does today's embedded processor stack up against, let's say, its 5-year-old predecessor? Both in raw compute muscle and let's say also in power consumption.
For example, when it comes to AI, it started to process AI just what is available on a single core. By now, we see that due to power efficiency, neural network accelerators were integrated both on the NPU side and as well on the MCU side. Of course, this always related to what the particular core or a compute system is able to achieve. It doesn't make sense to add immense AI processing power on a system that can't cope with all the data to bring in and get out of the device.
Ulrich, you've mentioned AI accelerators earlier in this episode. Now you've just mentioned MCUs, MPUs. Let's clarify something fundamental for our audience. EBV offers MCUs, MPUs, and AI accelerators. Could you break down the key differences between these technologies?
Certainly. Good question. Let's start with the AI accelerators as they kind of bridged the gap time-wise to come up with AI-based solutions. We started onboarding a supplier for AI acceleration products with a very powerful device that got interfaced via PCI Express. And over the course of time, these type of neural network accelerators became something like a commodity IP block, as with other peripherals like GPUs, like network blocks, to be added to MCUs and MPUs. Of course, MCUs are typically found in systems that don't have the need for high compute power. Of course, with the benefit of being typically on a much lower power budget, whereas MPUs can deal and host operating systems, can deal with larger data, sheer processing power to process different things like more complex, more high resolution videos, for example. And that's how I would separate these three products in general.
I think that's helpful. When we look at our listeners, many of them are looking to integrate AI into their projects. What's your framework for selecting the right embedded processing solution, and how does EBV support customers through this decision process?
You are addressing a very valid point here. In the jungle of products available, it's EBV's mission to help and support customers to find the right embedded processing solution. This including products dedicated for AI applications. But it extends to all semiconductor components that are required for either a chip-down solution, respective with EBV's embedded solutions, to pick the right module or complete system from a wide offering of products in case customers want to buy versus make. And it even further extends as we can offer passive components from our Abacus speedboat that is also part of the IMARC Group, where EBV also belongs to. And last but not least, it is an internal and external partner network we maintain to refer customers find the right partner for software development or software solutions.
Beyond AI, what emerging trends are reshaping the embedded processing landscape? What should our audience be watching, Ulrich?
Good one. Well, after more than 30 years, I'm in this semiconductor business. It's still a very exciting area to follow the trends in embedded processing. For example, there's the convergence of MCUs and MPUs. Lower power MPU cores also address markets that were previously covered by high performance MCUs, whereas RTOSes that are typically run on MCUs become more powerful with features and stacks that are more full OS-like. And here, for example, Sapphire to name one of them. Another one, the entry class on one side get more and more powerful peripherals and high-end MPUs, additional IP blocks like the neural network accelerators, pushing out the limits for AI. Another one would, for example, be monolithic dies that are replaced by dedicated tiles like the processing units, GPUs, and NPUs to make a system on chip tailored exactly to the customer need. And just recently, while ARM-based systems for notebooks are at a point to run OSs like Windows at the same or sometimes even better performance level, they are about to be seen in industrial products as well. And very likely, I miss a couple of other trends, as this is such a dynamic area we are operating in.
Yeah, I concur. It's incredibly dynamic. And you know what? You gave a great overview. And, we'll have more opportunities to dive into this space is my feeling. Ulrich, let's wrap up with the all-electric society theme at your Embedded World booth this year. How do embedded solutions fit into this vision of an electrified future, and what can visitors expect to see at the EBV booth?
I consider embedded solutions the heart or brain of a product that is found in this all-electric society, meaning all these kind of products are by now connected. We're used to get real-time information wherever we are in the world, and where embedded processing is simply one of them. Here we will showcase or in a demo at our booth the newest products and solutions from our silicon suppliers. And I can just invite you to our booth in Hall 3A, booth 125, to have a relaxed chat or exchange with our experts to discuss your products or trends. Yeah, you should be prepared for your new products.
I think that sounds very exciting. Ulrich, you've been on the show before, and we're fortunate enough to have you today, and you gave us a great overview about the whole embedded processing space and its trends. Now, you know our tradition of closing out every single episode with me asking for the roots of your passion for technology. So let's discover and let's explore more about your past and where your passion for technology originated from. I hope that you had a chance. If not, take the time now to dive deep into your past and share with us your passion for technology.
Yeah, I would say in particular, and as I stated, following the trend of AI and all the hype that came with AI from products like ChatGPT, it's really so fascinating to see how products became autonomous operating, to see how over the course of time neural networks improved, being adopted even on smaller MCUs to fulfill different tasks. And this is really looking at what's possible, but also, of course, trying to be a bit cautious on where we are heading to when it comes to utilizing AI. This is something that I'm still interested in, as I stated, being more than 30 years in this business.
Thank you. Thank you, Ulrich, for the insights that you've shared with us today. Dear listeners, as always, you can find more info in our show notes. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Ulrich, thank you for joining us today.
Thank you very much for being on this podcast.